Important disclaimer before we get into today's episode. Currently, SpaceX is working on reaching Block 3 or V3 of the Starship development. But that won't be the end of the Starship program, because after that comes Block 4 or V4. At least if you go by SpaceX's public plans. Apart from this graphic, there isn't much video material of it, because V4 is at best a year away, but probably several years in the future. What I'm trying to say is that this video is only for the Starship Ultras who already want to think about possible future prospects today. Some information is public, some is not, so this video also includes a bit of speculation. I just wanted to clarify that in advance to set the right expectations. And now, on to the actual video. A quiet hum in the factory halls of Starbase, where steel and visions merge. Starship Block 4 is taking shape, longer and hungrier than ever before, while rumors about a 12-meter version are stirring up the spaceflight community. Today we're digging deep into this evolution. The upgrades of Block 4, the opportunities and pitfalls of a thicker ship, the headaches with the existing infrastructure, and even adventurous ideas like 3 super heavy boosters joining together to form a Colossus. We calculate the possible payloads and see how SpaceX is once again rewriting or could rewrite the rules. First, to the core. Starship Block 4 is supposed to build on the successes and insights from Block 3, which we will see in the upcoming flights. Block 3 has already integrated the interstage without jettisoning it, which maximizes reusability and reduces costs, but Block 4 goes further. Elon Musk recently tweeted, that version 4 or V4 includes a longer ship, about 10 meters per vehicle, which brings the total height to 142 meters. That primarily means more fuel volume. The upper stage goes from the initial 1,200 tons of methane and liquid oxygen to 2,300 tons. The booster goes from 3,250 to 4,050 tons, and the booster engines remain at 33 Raptors, but the ship gets 3 additional ones, making 42 in total. The answer to everything. Each Raptor 3 delivers 280 tons of thrust, which raises the total thrust to over 10,000 tons, 3 times as much as the Saturn V. That sounds epic, and it is. With more fuel and power, Block 4 will carry payloads of 200 tons into low Earth orbit, and that's in reusable mode. That's a significant increase from the supposed 15 tons of Block 1. Imagine not just sending satellites, but entire space stations, modules for moon bases or Mars habitats in a single launch. SpaceX is already testing it. At Starbase, cryo tests are underway for Booster 19 and Ship 39, which integrate elements from Block 4 with a planned Flight 12 in early 2026. Production in McGregor is accelerating. They're building more than 1 engine per day, and with optimized manufacturing processes, the cost per Raptor is dropping below $500,000. That's why we'll see a drastic increase in the test cadence in 2026. In 2025, we enjoyed 5 test flights. SpaceX is really ramping up, and this could be the year when Starship goes from sporadic tests to a real flying machine. The FAA has just given the green light for up to 25 launches from Starbase, a 5-fold increase over previous limits, showing that regulators are finally keeping up with the pace. Elon Musk is talking about dozens of flights, maybe even weekly launches, if everything goes smoothly and based on the progress in production. This will be the first deployment of version 3 with improved Raptor 3 engines and new avionics for precise docking. All of this is to perfect reusability, or even to achieve it in the first place. In addition to pure test flights, which could push the cadence to 20 to 40 real missions, will be added. In the summer, an in-space propellant transfer test is scheduled, where 2 ships will dock in orbit and transfer fuel. A game changer for long-distance flights, and then the highlight at the end of 2026. During the Earth-Mars transfer window, unmanned starships are supposed to launch, possibly loaded with Optimus robots or even a few Cybertrucks, which will begin building the first infrastructure on the Red Planet. Depending on the number of operational launch facilities, between 2 and 6 starships could already set off for the Red Planet. Each such mission requires 10 to 20 tanker flights for refueling in orbit, which makes the total number skyrocket. At the same time, SpaceX is planning an unmanned lunar landing for the human landing system as part of Artemis, with crewed flights for Artemis 3 scheduled for the middle to the end of the year. That would establish Starship not just as a test vehicle, but as a true explorer. Of course, as ambitious as that sounds, are there any catches? Technical glitches like with Booster 18, where a test went wrong, can delay the schedule, and the FAA could slow things down with every anomaly. And if Block 3 starts its career as successfully as Block 2, then we can already prepare ourselves for a series of setbacks. Until all the teething problems are ironed out, and not just the teething problems, but also a whole bunch of completely new capabilities. Like docking and transferring fuel, long-term lossless storage of fuel, life support systems, catching and reusing ships, accelerating to and decelerating from the moon, as well as landing and operating on our natural satellite, just to name a few examples. The infrastructure must keep up. The second tower at Starbase and Pad 39A in Florida are expected to catch Starship starting in mid-2026. But until then, everything depends on reliability. And honestly, a weekly schedule would be epic, but realistically we'll end up with 20 to 40 if production, one engine per day in McGregor, the new gigabase, and the test flights don't stumble. Still, the potential is breathtaking. From Starlink Phi 3 batches to orbital data centers, Starship will deliver 99% of the payload mass into space. If that works, we'll be a huge step closer to colonies on the Moon and Mars. And that makes me really optimistic about what's coming. But let's be honest, longer ships also bring headaches. The aerodynamics change, more length means a higher bending moment, and so something structural has to happen here, which increases the weight. That also increases the mass again, which in turn has to enter the atmosphere, so more energy that has to be dissipated, which means a greater load on the heat shield. Currently, Starship weighs about 250 tons when empty. With Block 4, that could rise to 300 tons, which increases fuel consumption. But the last test flights seem to have made SpaceX optimistic, since the ship survived re-entry even though tiles were deliberately left off at critical points. Compared to earlier blocks, Block 4 is a quantum leap. Block 1 barely made it into space and only parts of it returned to Earth. Block 2 stabilized that with better flap designs and an improved heat shield. And Block 3 now integrated a new attitude control system, a new engine generation, and many other lessons from the previous 11 flights. Block 4 adds efficiency. The specific impulse of the Raptors increases to 355 seconds thanks to optimized nozzles, which means 5% less fuel for the same orbit, compared to competitors like Blue Origin's Nucleon, which only lifts 45 tons reusably, or National Aeronautics and Space Administration's Space Launch System with 27 tons. Starship is unbeatable. But the risks? Initial flights could fail, just like with the first Block 2 flights, where different problems caused several setbacks. These included harmonic resonance, problems with the engines, and fuel supply issues. However, some of the difficulties were due to the Raptor 2 generation. So that should get significantly better once the next version goes online. Starbase and Florida are expanding infrastructure, adding a gigabase for longer ships. By 2027, V4 is expected to have partnerships like National Aeronautics and Space Administration for Artemis, where Starship serves as a lander, as well as international partners like Italy and South Korea for Mars missions. This opens doors for lunar bases by 2030. But also, a new internal SpaceX business model with gigantic data centers in space will drive an incredible launch cadence. Now to the rumors about a 12-meter Starship. Yes, Elon hinted at it once, and in 2025 the forums are buzzing. Currently, Starship is 9 meters wide, which is perfect for transport and production. Not by chance, but because the entire infrastructure is designed for it, meaning the production line, the transport routes, and the launch facilities. But 12 meters would increase the diameter by a third, from a radius of 4.5 to 6 meters. The tank capacity scales with the cross-sectional area, so with the square of the diameter. So by increasing the diameter by 33%, we get a tank size of 178%. The dry mass scales linearly, but the volume scales quadratically. The advantage is that with about 30 tons of additional dry mass, the payload capacity doubles. Perfect for large cargo flights to Mars. Imagine sending entire factories up in one piece or building orbital stations faster. The thrust scales up. More room for engines, maybe 50 Raptors on the booster for 14,000 tons of thrust. The efficiency increases because larger tanks improve the mass ratio, less steel per ton of fuel. Right, a Starship could easily bring 250 tons to low Earth orbit with full reusability, but the large tanks would rather make it a low Earth orbit workhorse. While the 9-meter variant would then be considered the transport of choice between celestial bodies. But the disadvantages are massive. The infrastructure is designed for 9 meters. The pads, transport roads, even the Starship factories. An upgrade would cost billions. New cranes, adapters, wider workstations, and reinforced pads to handle the higher thrust. But SpaceX doesn't shy away from colossal tasks, like with the Falcon Heavy, where they rebuilt pads and even had to modify the Falcon 9 structure. But with Starship, it's a whole new level. SpaceX would probably have to build an entirely new factory, and the launch facilities would either need to be heavily modified or built from scratch. However, they would definitely benefit from the development sections of the smaller version, which is certainly a big advantage. At the moment, there is absolutely no sign of such a project. Nevertheless, it could be that a small team at SpaceX has already started working on the design. Elon has already said several times online and in interviews that it's doable, but it doesn't have any priority at the moment. Because first, they need to get Starship with the 9-meter diameter operational, focusing on reusability first. Still, a 12-meter Starship is fascinating. It could allow Mars missions to carry more settlers per flight, expand asteroid mining, and transport tunnel boring machines to the Moon and Mars. And what about the wild idea of 3 super heavy boosters strapped together like the Falcon Heavy, only even more epic? A central booster with 2 side boosters, each with 33 Raptors, delivering a total thrust of 30,000 tons. Payload. With Falcon Heavy, the capacity almost triples from 22 to 64 tons. For Starship, that means 500 tons to low Earth orbit in reuse mode, over 1,000 tons in expendable mode. Perfect for megastructures like orbital rings or fast Mars fleets. The advantages are that it uses existing technologies, no complete redevelopment, the side boosters land separately, and the central booster keeps boosting. But realistically, integration is a nightmare, synchronizing vibrations, managing fuel transfer, and keeping the structures intact. Falcon Heavy took years, and Starship is many times bigger. That would be very exciting for large telescopes and other infrastructure. However, the disadvantages are the higher costs per flight and much more complex launches. But SpaceX is more focused on rapid cadence, not monster boosters that only launch once in a blue moon. They only developed the Falcon Heavy to satisfy the military. That's another story. Nevertheless, when Block 4 is running, the development team at SpaceX will turn to a new system in the 2030s. What do you think that will be? Will they focus on a new spacecraft or rather on surface structures for the Moon and Mars? To sum it up, Block 4 makes Starship longer, stronger, and more efficient with a 200-ton payload and flights starting in 2027. A 12-meter upgrade would double that, but would require rebuilding the infrastructure. For that, it would have to be clear beforehand that it's worth it, and that the new version has capabilities that the 9-meter version doesn't have. Triple boosters, such as Falcon Heavy or Delta IV Heavy, speculative. But 500 tons of payload might open doors to real colonies and long interplanetary journeys with humans. Maybe that's also the version that will make asteroid mining possible in the first place. Challenges like costs and risks are there. But that has never been a deal breaker for SpaceX. What the future holds is still unclear. But what is clear is that the world is currently changing rapidly, and that the future holds breathtaking things for us. If you enjoyed this exploration of the Starship future, subscribe to Mars Chronicles and leave a thumbs up. Thanks so much to all channel members and Patreon supporters. If you also want early access to our videos, you can find all the information about it below in the video description. My name is Serwin, and this was Mars Chronicles. Thanks for tuning in. Per Aspera ad Astra.